You can make money with meteorites. Even the ones that are not very valuable, the least valuable types, are worth like $500 a pound. And the more valuable types, well, they're worth as much as platinum or some other super precious metals, almost as much as gold. They can be really, really valuable. And, they've been in the news lately. It was just a week or so ago that there was a super bright, what they call a super bolide meteor. This was so bright that it lit up the sky at noon. Even during the sunlight, it was bright enough to light things up. And it streaked over the Carolinas and that part of the country. And there was this boom as the thing exploded and burst into bits. Some bigger meteorites, because they're cold from space, and then they hit the atmosphere and heat up so hot that it melts the surface of the rock. The hot and the cold together cause the thing to just crack and break up and explode. So the meteorite shower that happened just recently, that super bright meteor left a trail of smoke or particles and stuff that was so bright it could be tracked on a satellite. And they tracked it from Tennessee all the way down into northern Georgia, where it impacted. And actually some of the pieces went through somebody's house. I don't think anybody was hurt, but you can imagine how surprised you'd be if a meteor went through your roof. Oh, let me show you a picture of it, because they had dash cams that got pictures of this thing. It's amazing.
Just look at this thing. It's broad daylight and the thing is lighting up the sky. They were able to track this thing like on radar because there was so much debris field left behind. It's falling off bits and particles. But they tracked it through Tennessee all the way down to Clay County in northern Georgia. And usually if you're able to find something, a fresh fall like this, especially something that made the news, if you're there in Clay County, fresh falls like this can be really very valuable.
A number of prospectors in the western United States find meteorites just when they're out metal detecting or out searching for gold. There's a story a friend of mine told that some years ago he was metal detecting in northwestern Arizona. And a guy that he knew also metal detected in that area. And that guy went through, and it was known by most prospectors that worked that area that there was some really nasty hot rocks out there that just screamed, and you could dig them. Most hot rocks are pretty near the surface, but these ones you could dig deep. It screamed even if they were down 6 inches or a foot or more. And so whenever prospectors found these really nasty hot rocks, they would just toss them aside or drop them back in the hole or something like that. And this guy, the friend of a friend, he looked at these hot rocks and thought, man, these things look really weird. So he took them to a geologist, and the geologist told him, that kind of looks like a meteorite. You might have that investigated. And he took it to someone who was an expert on meteorites. They tested it, and sure enough, it absolutely was a meteorite. And it was basically, because there was so many of them, it was what they call a strewn field, where a big meteor exploded in the atmosphere, broke up into a whole bunch of different pieces, and landed in a pattern. That's what they call a strewn field, where you have pieces that go out for a certain distance. Usually the strewn fields are long and narrow because the meteor comes down, boom, and it blows and goes into all these pieces, and it becomes a strewn field. And so he and my friend got permission and went around and collected these things. And a lot of times they would go to, and they would see where somebody had dug, and right next to it would be one of these unusual stones, one of these meteorites. They actually, if you broke them open, had pieces of metal inside them, and pieces of nickel iron alloy. And so basically natural stainless steel kind of stuff. And they collected these things, and they were submitted for science, and they were studied and all kinds of things. And they're very valuable, well worth having. So if you want to make some money, if you happen to come upon a meteorite, or if you want to go out into a strewn field and chase meteors where it's known that they've laid down, and some other places that are known to have meteors and be profitable for prospectors, I'm going to tell you all about that. I'm going to tell you where they come from, what they're like, what the characteristics are like, and you, by the time you watch this video, you'll know enough to identify one for yourself, and you'll know if it's a meteorite and valuable or it's just a unusual rock and not really worth anything. But I'm going to start with telling you about the origins of meteorites. Now, meteorites, most of them are basically bits of asteroids, sometimes asteroids that have collided with each other and gotten knocked out of their orbit. Some of the little ones that we see when we look up in the sky and you just see a bright little streak across the sky, those are can be bits and pieces of comets that have come off. And a lot of times the little ones we see in the sky, not the super bright things, but the little things, they're like a grain of sand or a pea size. It doesn't take a lot of rock to make a lot of light. What happens is the rock streaks through the atmosphere, becomes superheated, it ionizes the gas of the upper atmosphere around it, and that's what lights up. It's the incandescent ionized gas that lights up, and that's what we see. You don't really see something that's many miles away that's the size of a pea, right? You wouldn't be able to see something like that. But because it ionizes all the gas around it is why it lights up and is such a spectacular thing. I've seen some pretty spectacular meteorites in the sky when I was out camping or prospecting at night, of course. I've never seen one that's bright enough you can see in the daytime. But they're interesting to watch, and they're interesting to collect, and they're valuable if you ever want to sell them. So to get started, let's talk about where meteorites are found. Do you know that in the United States, almost every state has had meteorite finds? So this isn't just a West Coast thing where, you know, West Coast guys find gold. This is all over the U.S. Even Florida and Hawaii have meteorites found in them. The only states that haven't are Vermont, New Hampshire, and Rhode Island, mostly because they're small, so there's not a lot of ground that the meteorite lands on, but then because especially Vermont and New Hampshire are more mountainous, and you know, if any meteorites that land there might get lost among the trees and the brush and everything else. So those are the three states. Every other state has had meteorite finds, some quite a few. So let's take a look at the places that meteorites are found, both in the US and worldwide.
Here's a map that shows the number of meteorites found in each state. You can look at your own state, but see that most of the states have found some. It varies. In the Northeast, you know, Vermont and New Hampshire, we have 0. Rhode Island, it's so tiny, 0. And there's a lot of them spread across the United States. But if you look to the west and southwest, you'll see that Texas, California, Arizona, New Mexico, Nevada, of all well over 150. Colorado and Kansas have significant numbers, but most of it we're talking about arid areas in the southwest United States. That's where the most meteorites have been found. Okay, here is a list, a map, or basically divide, showing where meteorites are found, kind of dividing it up by continent and other major land areas. And you can see that Antarctica is the source of a huge percentage of the meteorites. You have white, snow, and ice, light-colored and dark-colored meteorites landing on top of it. And so they stand out very easily. Same in northern Africa, you have the deserts with light-colored sands, and the dark-colored meteorites stand out. The Arabian Peninsula, again, desert area, light-colored sands, the dark-colored meteorites stand out. Although North America is only 3.3%, Australia 1% plus, and everywhere else, Asia and all combined, is only 3%, still there are places in those areas where a good number of meteorites are found.
So let's look at some of the different types of meteorites that are out there. Meteorites are divided into basically 3 broad categories: stony meteorites, stony iron, so that's stone and iron, and then irons, okay? So those 3 types are the main types that we're going to talk about. They're the main, there's different subclasses underneath those, but those are the main broad types. So let's first talk about the stony meteorites.
Here's an example of a stony meteorite. It consists of various little round dots, as you can see in there. We're going to talk more about those in a bit. They're called chondrules, and it basically doesn't have any iron in it, but you can see the fusion crust that was melted all around the surface. That gives it away that it was indeed a meteorite, even though it doesn't have any iron in it. Here's another stony meteorite. It was found a while back not far from Los Angeles, just north of LA in the desert area, not far from Palmdale. And a guy who found it knocked the tip off there, and they analyzed the piece, and it was shown to definitely be a stony type iron-free meteorite.
And now that we've considered the stony meteorites, let's talk about the stony irons. This is rocks that have some iron metal and some rock, and those are the type that just scream on metal detectors because the iron alloy inside them, it's an iron nickel alloy. That stuff just screams on metal detectors. And so let's talk about those.
Here's a stony iron type of meteorite. Where it's mostly stone, but all the white spots in this are metallic iron alloyed with nickel. And so this is what the stony irons often look like. It's mostly rock, but it's got significant iron in it. If you go over this type of rock or type of meteorite with your metal detector, because of all the iron in it, it will scream and make a loud target sound. This is also a stony iron meteorite, although this is just a slice. It's not a whole meteorite. They made a slice through it so you could see through the crystals that are in it. This is called a palisite, and it's a very valuable type of meteorite. It has a lot more iron than the ones I just showed you, and of course that would sound off very loudly. Then inside it are crystals of olivine.
And finally, the third type we have is called the irons. These are basically parts of meteorites that are mostly the iron nickel alloy with little or no rock to speak of. And so these are another type that we get that land on Earth.
Here's a typical iron meteorite. This is actually part of the Canyon Diablo meteorite crater in Arizona. That thing had a mostly one impact, but there were side pieces that shot off as it entered the atmosphere, and this is one of the side pieces. It's really not that large, but it weighs 67 pounds because it's nearly solid iron nickel alloy. And this is the interior of an iron meteorite. And it, although just on sawing it won't display this pattern, but if you etch the sawed surface, then it will display this crystallization pattern. It has to do with crystallization of iron alloys that are both high and some low in nickel content.
So we talked about the different types. Let's talk next about the characteristics of meteorites. You find an unusual rock. Is that going to be a meteorite? Potentially, I guess. But you want them to fit these characteristics that belong. One of the first things is that the rock can't contain quartz, which is like the most common mineral on the surface of the earth, or calcite, which is what limestone is made of. It can't contain that mineral either. No examples of meteorites ever contain those. But they have other characteristics, and probably the first one among them is that they're heavy and compact. So you don't get meteorites that are shaped like a flat slab. They're more compact. They don't have to be a sphere, like a giant bowling ball or something, but they're generally not, long in two directions and thin in the third, like a slab, that kind of thing. They're compact and they're heavy. They tend to be, because a lot of them have some iron in them, and even the ones that are iron metal free, they have iron minerals in them, and so they tend to be on the heavy side. Of course, there's a zillion terrestrial earth rocks that tend to be on the heavy side. Another thing about being compact is that they don't have holes in them. There is a common volcanic rock that's heavy and dark, and but basalt a lot of times has what they call vesicles, which is basically air holes. As the lava comes up, there's actually dissolved air and steam in the rock, and as it comes to the surface, it comes out of the rock and forms these bubble shapes. And so if you find bubble shapes in the rock, like depression bubble shapes, not bubble out, but bubbles in the rock, that's not going to be, it's going to be basalt. It's probably going to be, it's not going to be a meteorite. So heavy and compact, and dark usually. Now the dark can vary. I've shown you some that are kind of a medium brown meteorites I've shown you pictures of already. And so, the color is not as critical, but things that are really light colored, like buff or tan or off-white, those aren't going to be meteorites. They're always at least like a medium brown to, a lot of them actually are black, but they tend to be dark in color. But there's a lot of earth rocks that are heavy and dark in color. So, but that's one characteristic that we can look at and say, yes, there you go. Another one is that they tend to be magnetic. Now the irons and the stony irons, they tend to be real magnetic. And it just so happens because a lot of meteorites are actually found with metal detectors by prospectors or by people who are looking for meteorites. The iron in irons or stony irons just makes the metal detectors scream. And so a lot of them are found that way. The ones that are just stony ones, they don't stand out as much, but they still have the fusion crust and some other things, some other characteristics we'll talk about in a second. But they all tend to be magnetic. That's what, one of the characteristics. If you have a rock and it's not at all magnetic, even weakly magnetic, it's probably not a meteorite. The next characteristic we want to go over is the fusion crust. What happens when meteorites, they're out there in the cold of space, super cold, and as they hit into our atmosphere, they start to have friction with the air of the atmosphere, right? Even in the upper atmosphere where the air is really thin, it starts to pick up, and just like the spaceships that come back in from orbit or from the moon or whatever, the friction with the air heats it up, and actually they heat up the meteorite so much the little tiny ones actually burn up. They just fall apart because they're basically burned up. But the bigger ones that make it through, that survive to be a meteorite on the ground, the surface of it gets melted. It's so hot. It's crazy hot. But what's funny is it goes so fast through the atmosphere that the surface can get melted and the interior of the thing is still cold. And so it never melts the whole piece of the rock like a tektite or other type of volcanic related rocks that were melted all the way through. Meteorites are not melted all the way through, but they have a surface, a thin surface that's basically a glass. So, one of the things that people do is in the desert, in a lot of areas, there's rocks that have what's called desert varnish, or, and if there's enough of the desert varnish rocks, sometimes called desert pavement. The rocks that have this desert varnish will have a coating of dark colors. You could have a light colored rock or a medium dark colored rock with a near black coating on it. I've seen zillions of rocks like that in the desert. It's pretty common. But if the fusion crust is actually melted, and if you look real close at those the desert pavement rocks or the desert varnish rocks, it doesn't look melted. It looks dark, but it doesn't look melted. And the fusion crust is melted. So let's take a look at some examples of fusion crust and the melting that goes on.
So here's a stony type iron meteorite where you can see the fusion coating is very dark brown, near black. On the inside, the part that's exposed, the little white spots are the metallic iron in the rock. But you can see the skin is thin and very different from the rest of the rock. I've shown you this meteorite before, but it is a good example of a fusion coating on a stony meteorite, non-iron type. And you can see it's just like this surface has been melted, but it's very different from the inside of the rock. This piece is brown fusion coating. It's not black, but the color is less important than the nature of the coating. It does look like it was melted on the surface. And here's a photo showing the fusion coating on an iron type meteorite. And again, the surface looks melted and is smooth. And so this is exactly what's happened. It's melted on the surface, whereas the inside is not melted at all.
One of the things you want to do if you find something that's a suspected meteorite is knock a corner of it off so that you can see inside. And you'll see inside a real meteorite that they have a thing called chondrules, the ones that have any stony content. If it's a solid iron meteorite, that's a whole different class that we've talked about, and that's an unusual. You find something that's solid iron, well, it's either going to be man-made iron or it's going to be a meteorite. But these chondrules are basically rounded little. They're not spheres. They can be spherical, but they can be oblong or round-ish. They're little roundish things that come together to form the rock. And these were actually formed early in the formation of the solar system. These little round bits have come together to form this rock. And then in the stony irons, you have basically the little roundish chondrules, and you have some metallic iron in the spaces between them. And so if you knock off a corner and you can see iron, or you see these little roundy little things, there's a good chance you've got, in fact, almost 100% chance that you've got a meteorite. So let's take a look at these chondrules and metal that make up these stony irons, which are actually the most common found type of meteorites that people find with their metal detectors or, out when they're hiking around.
Okay, here's a meteorite where you can see the round chondrules in it very easily because the ground mass is lighter colored and there's different colored these round chondrules. And of course, they're not perfectly round, but they're roundish. And the white in the material, like the line of white and other white spots, that's metallic iron. And then the dark around the edge is the fusion crust. And you can see the fusion crust rather plainly surrounded this meteorite. I wanted to show you this one to make the point that the chondrules are not always super duper obvious. If you're looking at this on a cell phone, you may not be able to see it. But if you're looking at it on a larger screen, you'll see that there are rounded spots in the ground mass of this. The white again is iron, but there's rounded spots through here throughout it. The problem is that the ground masses are medium gray and the spots are kind of medium dark gray to medium light gray. And so there's just not a lot of contrast in color. But if you look at this closely, if you stop the video and look at it real close, you'll see there's round chondrules all throughout this. And then, of course, the white iron too. So this is clearly a meteorite.
The next characteristic we're going to look at is a real unusual. Not every meteorite shows this very well. Some of them really do. It's called regmaglyphs, which is an unusual word, but it's basically sometimes called thumbprints in the rock. They're little depressions that are caused as the rock goes down through the atmosphere and the surface is melted. You get these little divots that are basically carved into the rock by the high heat of running through the atmosphere. And so they have a characteristic thing. Let me show you what these look like.
Okay, here's a large iron meteorite, and you can see these thumbprint depressions in the surface of it. And because this is a large piece, it's maybe 3+ feet in the longest dimension. These thumbprints, the regmaglyphs, are several inches across. Here's a very small iron, and you can still see the same regmaglyphs in this surface. But because this is only a couple inch long piece, the depressions, the thumbprints, are very small, maybe even smaller than my finger.
Another characteristic that's related to basically the melted surface is what they call flow lines. And sometimes there's enough melted that there's actually a little bit on the interior may still be cold, but the surface melts enough that you actually have a little bit of flow lines of the material on the surface, which is basically a glass, right? You melt rock and you get a glass type of material. That's what the fusion crust is. It's kind of a dark glass. And so when you go through it, you may have on edges and corners these little flow lines. Let me show you a little bit about flow lines. Not every meteorite has these.
Not every meteorite has this, but here you can see on the edge of this meteorite, it looks like it melted, and the melt, just a very thin amount, flowed from the edge of the meteorite. Here's an iron meteorite, and you can see again on this edge, there's some thin lines of where a little tiny bit of the iron actually flowed across the surface.
And finally, we'll talk about nickel content. That's another characteristic of meteorites. Even ones that just are stony, have unusually high levels of nickel in them. The ones that have metal, that have, the metal alloy is high in nickel, unusually high in nickel. And, nickel is found on Earth. Of course, there's nickel deposits. We use nickel as a metal. But meteorites happen to have just unusually large amounts of nickel. And so one of the quickest, easiest tests that people do, and I've been to places like Tucson where if somebody brings a meteorite in to test it, they can test it right away, is they take what's called an XRF gun, and these are expensive. They cost upwards of $30,000, $40,000, $50,000 a piece. But for the guys who are professional meteorite handlers that sell them, that buy them, they can take one of these guns, put it on the rock, pull the trigger, and if it comes back, it's basically zero nickel. They know it's not a meteorite. It comes back, 2 or 3% nickel, and it's an unusual looking rock. Well, that's a reliable indicator that it's a meteorite. Now I'd say, hey, that's super quick. You just have somebody test it for you with an XRF gun. But like I say, because they're $30,000 to $50,000 to buy one, they're not very common. Some people have them, and there's applications for them, but not everybody has one of those. But if you have access, there's a quick way to determine if your rock is a meteorite or not. So that's a little bit of a summary of the characteristics of meteorites. Okay, let's take a look at meteorites versus meteor-wrongs. It's kind of a joke in the meteorite world that meteorite is a proper meteor, and a meteor-wrong is something that somebody's picked up that looks unusual, but it's not a meteor. It's a regular earthbound terrestrial rock. So there's certain kinds of rocks that people commonly mistake for meteors. Meteorites there's 3 of them that they're the most common. Other rocks get mistaken too, but generally speaking, it's iron ores and iron oxide, iron ores, iron-rich rocks. The slags from smelting and that kind of stuff, and then also volcanic rocks, certain volcanic rocks. The iron ores get picked up because they're heavy, they're dark, they're unusual, and they're very magnetic. They tend to be pretty magnetic. And so people think, yeah, this maybe is a meteorite. I actually was at the Nevada Bureau of Mines one time. I was buying a book or talking to somebody, and some guy brought in a big chunk of iron ore, and he thought it was a meteorite. And I looked at it and said, that's a chunk of iron ore. So it gets mistaken. Slag gets mistaken because it's melty, and like I said, the fusion crust on a meteorite is a melted surface, so slag can have a melty looking surface. And then finally, volcanic rocks. Certain kinds of volcanic rocks look, and in fact, there's even volcanic rocks that have flown through the air, right? The volcano can shoot stuff out, and the rock flies through the air and gets a chance to, be shaped by flying through the air like a meteorite and lands on the ground. But it's still a volcanic rock. It's not really a meteorite that came from space. So let's take a look at some pictures of meteorites, the real thing, versus meteor-rongs. Actually, we're going to look mostly at meteor-rongs.
Like I say, the best meteor-rongs, a lot of them are iron ores. And, you look at this and you think, well, maybe those are all flow lines over the surface. It's smooth. It looked like it got melted. But this is just a natural chunk of iron ore. It's way too angular, and it's not what we're looking for. Another common thing is actual chunks of iron. And every once in a while when I'm metal detecting, I find some nondescript chunk of iron like this. And, most iron things you find in the ground are recognizable as a nail or a bracket or some other specific part that's broken off. But sometimes you get ones that are just don't really fit into any category. And this one is like that, but this is just a chunk of iron. It's not a meteorite. This is a piece of smelter slag, and it looks melty on the surface because, well, it did melt, and slag is molten material. But the inside of it looks exactly the same as the outside. There's no signs of iron or chondrules or anything like that. It's just a piece of molten slag that's solidified. Here's a piece of basalt. It has all these depressions in it. It kind of looks like those thumbprints. It maybe make you do a double take, but on looking closer, it's just a piece of basalt, a very common volcanic rock. Here's another unusual looking rock. And again, it's not a meteorite. But this is something that if you happened on this rock, you'd want to be sure and take it with you, because this is a big old chunk of jade. That's why it's green. It's jade. So, there are things out there in addition to meteorites that you might want to take with you if you stumble across them.
So finally, let's talk about where you can find meteorites. And generally speaking, the most common places to find meteorites are either desert type areas or glaciers and that kind of thing that are white. So you have Antarctica as the big source where a lot of meteorites have been found because, hey, white, and you find this dark colored rock in the middle of nowhere that, it's going to be a meteorite. I had a friend who went to Oman in the Arabian Peninsula and went out looking for meteorites in the light-colored sands. That the area is covered with sand and it's light-colored, and you can drive around and say, hey, there's a dark-colored rock, let's go over there, and a pretty good chance it's going to be a meteorite. So another thing is in Nevada, we have, and other places in the West too, we have these alkali dry lakes, and they're buff, tan kind of color, and rocks will land on them, and some of the rocks are meteorites. And what happens is we get cold weather here, and the surface of the thing freezes. The surface of the dry lake freezes. It gets a little water on it, and it freezes. And then rocks like these meteorites will actually get blown by the wind in a certain direction. And actually, sometimes of the year, you can see the trace of the rock. It looks really weird, like the rock has moved along because it's been blown by the wind. And so since the wind generally blows out of the north and out of the west, then the rocks get blown to the southeast type of direction. And so the southern and eastern side of some of these dry lakes, people patrol along them and look for meteorites. And I know people who've been successful doing that. So in light colored places, that kind of thing. And also strewn fields, there's known places where there's meteorites. Gold Basin in Arizona, like I talked about earlier. Franconia and some others. You can search on the internet for known strewn fields, and be sure you have permission to be on the land to find that stuff. But there are known strewn fields out there where a meteor has exploded, and pieces of rock have landed on the ground. But if you're out prospecting and you come across an unusual rock, don't just walk away from it. Test it out. Maybe take it with you. You knock a corner of it off. You never know. It could be something valuable. There's a lot of one-off meteorite finds where it's one of a kind. There's only one of them. It was not a giant rock that exploded into hundreds of pieces. It was a single fall that landed, and so those things can be unique and pretty valuable. So if you're out prospecting, if you're out with your metal detector, or you're out otherwise looking around and you come across an unusual rock, it might be a meteorite. Years ago in Nevada, some guys were out prospecting. This was down toward Tonopah, and came across an unusual rock, and it was a meteorite, like a good size one. It took them a lot of effort to get it out of the ground, but it's here at the museum at the planetarium here at the University of Nevada. After years of traveling around, it's back in Nevada here, and so you can find meteorites. Now, like I say, a lot of the meteorites that are found by gold prospectors, and prospecting for gold and running metal detectors and other activities of prospecting. It's a skill, and I wrote a book called Fistful of Gold that tells about how you can gain those skills. And also I have a partnership with High Plains Prospectors that sell metal detectors and other things that you would use if you want to get involved in this. And I'm going to tell you a little bit more about my book and about High Plains right now. This is my book, Fistful of Gold. It's an encyclopedia of everything you need to know to go out and find gold for yourself. It distills down my 45 years of experience out in the field prospecting, as well as my degree in mine engineering. It's, like I say, an encyclopedia. There's a lot to it. It's over 250,000 words long, hundreds of pages with hundreds of illustrations, teaching you what you need to know about geology, about mining districts, about techniques of finding gold. It covers metal detectors, sluicing, panning, dry washing, high bankers, you name it, it's covered in there. It talks some about platinum and diamonds, but it's mostly about gold because gold is more widespread. It is not so much a book about where to find gold, but a book about how to find gold. Because even if you have a location where gold was mined in the past and you go out there, well, where should you look to be successful in your prospecting, to find the gold that's there? This is the book that's going to tell you that information. I spent most of 10 years writing this book, so I thought a long time about it. It's got, like I say, lots of information and lots of illustrations, and I've had results from people who bought it. It's available on Amazon, but I recommend buying it through High Plains Prospectors, and I'll put a link in the description for buying this book through them. They have a better price than Amazon, and I have a special deal that I'll tell you a little bit more about, where you can get a 5% discount from the price even with that. On Amazon, the book rates a 4.7 out of 5, which means that of all the people that have bought it, they've been really highly satisfied, and I think you, if you buy my book, will be just as highly satisfied as well. Now let's talk a little bit more about High Plains Prospectors. They're a prospecting shop, a mail order prospecting shop that I've partnered with. The deal is that I can get you a 5% discount, a coupon code, and I'm going to put the code to that right here. It's just Chris Ralph, all caps with no space between Chris and Ralph. You put that in there as a discount code and you'll get 5% off their already really good prices. I think it's a great deal where you win by getting a discount, I get a little percentage of that, and they get new business. So if you need prospecting supplies, High Plains is really the way to go. And I'll put information, like I say, in the description more about how you can work with them, because I'm working with them. They really are great guys, a great company. For even more information, I also have a website, and I'm going to show you my webpage and talk a little bit more about that right now.
This is my webpage. It's located at NevadaOutbackGems.com. You can Google it, or I have a link down in the description below. But there's lots of information here, miscellaneous stuff, pictures, some historic information as well, stories. It's got a lot of great fun stuff. You'll probably be interested in it.
Now, on all of my YouTube videos, I encourage you guys to ask questions. If you have thoughts, comments, suggestions for things that I ought to look at in my videos, things that you want to find out more about, and I answer 100% of my questions. There's not very many YouTubers out there that answer 100% of their questions. I'm one of the few. And so I will do my best to answer what you have. I mean, I only can write so much. Sometimes the answer is something where I'm going to recommend that you buy the book and read about it. I also ask that you subscribe to my channel, click the bell notification so that every time I come out with a new video, you'll be able to watch it. And like I say, I cover a huge amount of topics. I also have 250 videos that I've already done. And so you can go back through my catalog of videos on YouTube. I'm sure there'll be many videos there that you'll want to take a look at, especially if you have any interest in gold or platinum, diamonds, gemstones, geology, and that sort of stuff. My YouTube site is going to be right up your alley. So I'll see you again real soon. We'll be out in the field and back in the office at the whiteboard, and whether we're looking at gold or platinum, diamonds, gemstones, or other interesting geology, it's going to be fun. You're going to enjoy it, and we'll see you again real soon.